In this video, we will write a C language program for generating AVL tree. So we will create a balanced binary search tree, that is AVL tree, by inserting the elements by performing rotations. So let us create a project and call the project as AVL trees as a C language program. So let us create this one. Here, let us start. See, the first thing, I should define a structure node for a tree. So in this one, we will have a pointer to a left child, that is struct node star L child, then integer data, that is the key element, then struct node star R child. Then for AVL tree, we should maintain balance factor for every node. So balance factors are calculated by the height of a tree, that is height of a left subtree minus height of right subtree. So here we will maintain height for every node. So in this way, we can get the height of left subtree and right subtree and calculate balance factor. So yes, this is height. So I'm introducing one data member, that is height of a node. Then I should have a pointer for a root node of a AVL tree. So I will directly declare a pointer here, that is a root, and I will initialize it to null. Then now we should perform insert. So for insertion, already we have written a function, that is a recursive function for inserting in a binary search tree. It will be almost the same function, just we will say take care of height, and if it is becoming imbalanced, we perform rotations. So I will copy the code for insert from binary search tree. So already we have seen that function, that same function I will copy it here. Yes, here is a function for recursively inserting in a binary search tree. I'll give a gap. So now you can see the complete function. This was the function we have written. Now while insertion, we have to take care of one thing, that we should also set the height. And we know well that in binary search tree, always a element is inserted in a leaf node. So when it is on the leaf node, then the height of that node will be 1. So inside this recursive insert, this is the place where I am creating a new node and inserting it. So after setting key, I will also set the height, that is at 1. See, one thing, if you remember, we have discussed the height. If there is just one single node, then the height is 0. But I am taking it as 1 onwards. Or else you can make it as 0 also. That's your choice. So I am starting height from 1 onwards. See, for example, I'll show you. See, there is suppose only one single node. Then height is 1. Then if it is having a child, then the height of a tree is 2. I'll be taking it as 2. This is 1 and this is 2. Right? We learned that we can start from 0, but here I am starting from 1 onwards. Okay? So if there is a single node, then its height will be 1. So then obviously the height of this one will become, from here, from the beginning, it will become 2. So if there is a single node, then the height will be 1, and then above this one, this node is there. So the height from here to here is total 2. So for this node, I should say the height from here is 2. This is the one thing. Then second thing, for every node, I should update the height. So recursively it is calling. So in recursion process, at the returning time, see this, all that calls, recursive calls are over. At the returning time, I should update the height of every node. So P's height, that is height of every node, should be equal to the maximum height of left subtree or right subtree. Whichever subtree's height is greater, that height we should take. So I have to check the left subtree height as well as right subtree height and take it, and I should take the maximum one. So for that, I should write down some code here. Instead of expanding the code here itself, I will write a function above here for calculating the height. So that function, I will directly use it here. Let us call that function name as node height. So I will call it as node height, height of a node. So for node height, I should send a pointer p. Then I will write on a function for finding the height of a node. So here above this R insert, I will first of all write a function for finding the height. So function node height. And it should take a struct node pointer. Then here I should check. I should find out the height of left subtree and also height of right subtree. And for the height of left subtree, I should check that first of all P is not null. Yes, P. As well as P's left child is there. P's L child. If it is there, then I should take the height of P's left child. Otherwise, the height should be taken as 0. Now same way, I should also take height of right child. That I will copy this one and paste it here. Only the difference is it is for right child. P is our child, then this is our child's height. Then after this, whichever is greater, in that I should add 1 and set the height of P. So here directly I will write down in return that if HL is greater than HR, then return HL plus 1, otherwise HR plus 1. That's it. So I should check the height of left child and the height of right child, and in that it will be plus 1. Just I'll show you. See, suppose in this tree, this is P. I want to know the height of this one. So height of this should be 2 and the height of this should be 1 because there is only one node and these are two nodes in the height of 2. So P's height should be whichever the value is greater. 2 is greater, so plus 1, 3. So yes, height of P is 3. That is 1, then 2, then 3. So this is how I am comparing and setting the height of P. So here, whatever the height of a node is sent by the function, I will take that in the P. So in this way, I'll be updating heights of every node. That's all. Till here, I have completed the code. So what I am doing is after inserting at returning time, I am updating the heights of each and every node. Now here I should write down the code for performing rotation. So for performing rotations, I should check the balance factor of each node, then perform appropriate rotation. So for this, I should know the balance factor of node P. After updating the height, I should know the balance factor of node P. I will write down the rotation function for two cases, that is LL and LR, and then remaining two are similar only. So let us write down the function. So first of all, I should have a function for finding the balance factor. So here I will write a function for returning balance factor. Let us call the function name as balance factor. Balance factor of struct node. I should take a node and find its balance factor. Now, balance factor is height of left subtree minus height of right subtree. So first of all, I should know the height of left subtree. So the height of left subtree is this one. I can copy this code, and the height of right subtree is this one. Already I have used it here. So copy these two things. Then, now I should return height of left subtree minus height of right subtree. Yes, HL minus HR. So the code is similar to finding the height of a node. There we were adding 1, but now we are subtracting height of left subtree minus height of right subtree. Now here I should check now back inside this recursive insert function. See, till here we have already seen just new line. This is the only new line I have added. Now let us write down the code for checking balance factors and deciding whether to perform LL or LR. So let us start using that balance factor and perform rotation. So if the balance factor of a node, that is balance factor of P, if it is equal to 2, means the node is imbalance. Then it is imbalance on which side? Left hand side, because its balance factor is positive 2, that is plus 2. And I should check the balance factor of left subtree or the left child of a P. So I will call balance factor of P's left child. Here is balance factor small a, and if it is equal to 1, means it is on the left hand side. So I should perform LL rotation. Yes, I should perform LL rotation. So I should call a function for LL rotation. So this logic I have to write down separately. This will be more than one statement. So let us make it as a function. So I will perform LL rotation upon P. And also I should return whatever the address that I am getting. Then similarly, I should perform all type of rotation. So I should check the balance factors and perform rotation. So I will write down rest of them. So I will copy this and paste it here. Now if the balance factor is true and the balance factor of its left child is -1, then I should call LR rotation. Then else if the balance factor is -2, that is it is negative, so it is heavy on the right hand side, then the balance factor of right child I should check, and if that is also -1, then it is heavy on right, so I should call RR rotation upon P. Then at last I'll copy this and paste it here. Now this is for the right child and the balance factor is -2 and the balance factor of right child is 1. That is heavy on the left hand side, so I should call LR rotation. Then I will implement all these functions and show you how these rotations works. So first let us write LL rotation. So here above this insert function I will write down LL rotation. So function will return a pointer to a node and let us call it as LL rotation. This is the function already we are using there. It will take a pointer to a node struct node P. Now how to handle this one? Let us check. So I have an example diagram I will show you there. So rotation is being performed upon node P. Let us see. See, suppose this is P, this node is P, and the rotation, that is LL rotation, is performed over this one. So what are the changes I have to do? I should make this node, that is left child of this P. So let us call this as PL. So this PL should become root and its right child should become, that is PL's right child. So let us call it as a PLR. Let us call it as a PLR. P's left child and right child should become a left child of P. So the after rotation, the node should look like this. I will draw them. This should be P and this should be PL and this should be PLR. So I can use 3 pointers or just by using 2 pointers I can do. But let us make it simple. I will take 3 pointers. Already P is pointing here on this node, upon this node. So I'll take PL and PLR and I will modify these. Now what about the height? See, the height of this PLR remains same because height we are counting downwards, so it will remain same only, and the height of a PL and P will change. So we will calculate it. So let us take 3 pointers and make necessary assignments. So what are the changes I have to do? P's right child should become P. So this is coming on the right hand side. Then the P's left side should become PLR. These are the 2 assignments I have to make and update their heights. So first of all, let us take these 2 extra pointers. Let us take struct node PL, that is P's left child. Then struct node PLR, that is PL's right child. So PL's R child. Yes, perfect. Now what are the assignments I have to make? PL's R child should be made as P. Yes. Then the P's left child should be made as PLR. Okay. Then I should modify the height. I should find out the heights of P and PL because PLR remains same. So let us call function that is node height and change the height of P. P's height is assigned with node height from P. Then the PL's height I should change. PL's height should be changed as node height from PL. That's all. Then at last, if suppose the rotation was performed about a root node of a tree, means if this P was equal to root, means root was Means if this root was equal to p, means root and p are same, then root should be changed to new node, that is new root, that is pl. That's all. After this, say return pl, that is the new root. That's all. This is ll rotation. Yes. Now let us check by inserting few nodes and see whether automatically this ll rotation will be performed upon a tree or not. So here inside the main function, I'll be calling r insert. So first of all, I should say root assign r insert by passing root and the key is 10. Then r insert root and the key is 5. This will come on the left hand side. Then r insert root, then 2. So this will be on the left's left. So if I draw the diagram and show you, this is how the tree will look like. So this will be imbalance and the rotation should be performed over this 10. So who should become new root? 5 should become new root. Let us check whether it works. Here I will put a bookmark and run and show you. Oops, there are warnings because I have not implemented rest of the functions. So I'll make them as comments. Okay, instead of comments, I'll write down dummy functions. See, for LL rotation also it's giving a error because in LL rotation I have taken a pointer. Yes, LL rotation R is not capital, R is a small. So I have changed that one. Then rest of the functions I'll just write down dummy functions so that it's doesn't show any warning. So this is one more, and this I will call it as LR rotation. Then one more, and this I will call it as RR rotation. And one more, this I will call it as. Then each function I should write on something, so I should return something, otherwise it will give an error. The functions are not returning anything, so write return null for each three of these functions. I will write on null for all of them. Now let us compile and see if there is any error. I will remove it. There is no error. Now let us see the node structure, that is tree structure formed here. Let us expand this. Oh, root is 5. See, root was 10. I have given 10 here. But here you can see that root is 5. Then its height is also 2. And its left child is 2. Yes, perfect. And the right child is 10. Yes, rotation is perfect. That's all. I'll remove the breakpoint. Now I have to show you one more rotation, that is LR rotation.